This diagram compares our global population against a 6-hour sleep threshold. Right now, over 2 billion people operate below that line. Most report feeling healthy, but when mapped against a zero baseline of biological safety, the deficit becomes clear. That gap exists because the subjective feeling of being rested has nothing to do with your actual physiological state. Missing that sleep triggers a physical reaction. While you are awake, a specific protein is silently accumulating inside your skull. Viewing sleep as downtime ignores an active biological threat that progresses during every waking hour. To see that threat, we must look past the exterior of the brain and enter the dense neural network where our memory and logic live. In the spaces between these firing cells, a sticky protein called beta amyloid builds up over the course of the day. As the hours pass, this protein acts like a physical barrier. It packs into the microscopic gaps, suffocating the surrounding brain cells and cutting off their communication. The cells choked off by this buildup are the ones responsible for memory retention, decision-making, and emotional control. When scientists examine the brains of Alzheimer's patients, this specific pattern of toxic buildup is the primary signature they find. Sustained wakefulness is a state of active toxic accumulation. It is a biological load your brain cannot carry indefinitely. The defense begins with the first slow electrical wave that washes over your cortex as you finally fall asleep. In 2012, researchers discovered exactly what that wave triggers: a hidden physiological cleaning system buried deep within your brain tissue. This network only engages during very specific sleep phases, requiring a low-frequency electrical environment to activate. While your conscious mind is silent, your brain tissue initiates a structural repair sequence that is impossible while you are awake. Deep sleep acts as the mandatory boot-up sequence for your brain's primary defense mechanism. Once that system reaches full capacity, the physical architecture of your brain begins to change. Look at this dimensional chart. During deep sleep, these brain cells undergo a physical contraction, shrinking their volume by up to 60. Yet tonight, millions of people will stay awake, scrolling through one more video or checking one more notification. During that time, the brain is trapped in a state of suspended readiness, waiting for the signal to initiate its maintenance cycle. This timeline visualizes your nightly maintenance window. With a fixed waking time, every minute you stay awake physically shrinks this repair sequence. Zooming into the first 90 minutes reveals peak density, when cellular shrinking and fluid flushing are most intense. This phase uses physical cellular contraction to clear proteins, a mechanical cleaning process that current medical treatments cannot replicate. An unbroken 8-hour sleep cycle is the irreplaceable biological requirement for protecting your cognitive future. The moment you close your eyes and begin to drift off, your brain initiates a highly choreographed biological transition. Within the first few minutes, the thalamus, a relay station deep in the center of the brain, begins to gate sensory input. Sounds become muffled and light signals dim. Your muscles relax as motor neuron activity systematically decreases throughout the body. This line graph tracks the neurological progression of stage 1. Brainwave frequency is dropping from the fast beta waves of waking life into slower alpha waves and then into theta waves. This initial 5 to 10 minute window serves as a preparation protocol, safely disconnecting the brain from the outside world before the structural work begins. Stage 2 begins with sudden bursts of electrical activity called sleep spindles, generated by the thalamus. These rapid oscillations fire at a specific frequency of 12 to 16 cycles per second. This animated cross-section shows the spindles acting as a biological filing system. They take short-term memories stored in the hippocampus and transfer them into the neocortex. Your brain is moving files from a temporary folder to a permanent hard drive for long-term storage. This stage is so critical to cognitive maintenance that it accounts for nearly half of your total sleep time. The impact of missing this window is quantifiable. A study in Nature Neuroscience found that people deprived of stage 2 sleep performed 40% worse on memory tasks the following day. Because stage 2 is where integration happens, cutting this phase short effectively deletes nearly half of your daily learning capacity. As you descend into stage 3 deep sleep, the brain produces synchronized delta waves that roll across the cortex like slow ocean swells. Your heart rate and blood pressure fall to their lowest levels of the cycle, and your breathing becomes rhythmic and deep. This physical state activates a hidden cleaning system called the glymphatic system, a biological pressure washer for the brain. During slow-wave sleep, the glial cells surrounding your neurons shrink by 60%. This shrinkage opens up channels between cells, creating a network of tiny rivers. Cerebrospinal fluid rushes through these channels, flushing out metabolic waste that has accumulated during the day. The primary target is beta amyloid, the protein that clumps into plaques in the brains of Alzheimer's patients. Research in the journal Science shows this system is 10 times more active during sleep than when you are awake. The wash also clears tau protein. Even a single night of disrupted deep sleep can increase tau levels in cerebrospinal fluid by 50%. Without this deep sleep phase, the brain's waste management system remains offline, leaving behind a daily residue of toxic proteins. While the cortex is being cleared of toxins, the pituitary gland at the base of the brain initiates a different systemic operation. This timeline shows that the pituitary gland secretes 75% of its daily growth hormone output during this first bout of slow-wave sleep. In adults, this hormone pulse drives cellular repair, strengthens immune function, and supports the maintenance of muscle tissue. By the time this 90-minute cycle concludes, your brain has reorganized memories, flushed toxic proteins, released repair hormones, and lowered systemic inflammation. These critical operations are completed before the brain has generated a single dream. The second half of the night shifts focus away from this physical maintenance to target something entirely different: your emotions. Many view a daily walk as a simple arithmetic equation: steps taken equal calories burned. However, by day 14 of a consistent routine, a complex physiological chain reaction has moved beyond the muscles and reached the brain. Every time your leg muscles contract, they act as a secondary heart. This rhythmic movement actively drives blood upward through the body, pushing it against gravity and into the skull. This comparison shows the surge in cerebral blood flow. While sitting represents the baseline on the left, walking increases the flow of blood to the brain by 15 to 25%. This increased volume delivers a steady supply of oxygen and glucose directly to your neurons, the cells responsible for every thought, memory, and decision you experience. Walking functions as a mechanical fuel pump. It provides the constant stream of resources required for the brain to maintain optimal cognitive function. The physical act of walking triggers the production of brain-derived neurotrophic factor, or BDNF. Biologists often compare this protein to a fertilizer because of how it encourages neural development. BDNF performs 3 critical roles. It stimulates the growth of new neurons in the hippocampus, strengthens the synaptic connections between existing cells, and protects neural tissue from the effects of degeneration. Researchers tracked older adults over a year. Half walked 3 times a week, half stretched. The walking group gained a 2% increase in hippocampal volume. The stretching group lost 1.4%. Normally, the hippocampus shrinks yearly. The walking group reversed this decline. Consistent daily walking replaces the volume lost to time, structurally rebuilding the brain's center for learning and memory. By week 2, the cumulative effect of these daily walks begins to alter your neurochemistry. The brain releases serotonin to stabilize mood, dopamine to drive motivation, and endorphins to generate a sense of well-being while reducing pain. This data from over 33,000 participants shows that even 1 hour of moderate exercise per week is associated with a 12% reduction in the incidence of future depression. Researchers estimated that if every inactive person met this minimum exercise threshold, roughly 12% of all depression cases could be prevented entirely. As the sun sets, the energy expended during those 10,000 steps builds homeostatic sleep pressure, the biological drive to sleep that accumulates throughout the day. Higher sleep pressure leads to a faster sleep onset and more time spent in deep, slow-wave sleep. A meta-analysis confirmed that this regular exercise improves sleep quality with an effect size comparable to prescription medication. By the end of the second week, walking serves as a systemic regulator, stabilizing daytime neurochemistry and forcing more efficient recovery at night. By week 3, measurable changes appear on the scale and in the mirror, though the underlying transformation is often misunderstood. For a person weighing 70 kilograms, Walking 10,000 steps at a moderate pace burns approximately 400 calories. Over a month, this creates a 12,000 calorie deficit. That equals roughly 1.5 kilograms, or about 3.5 pounds of fat loss. The scale often hides this progress because the body is simultaneously building lean muscle in the legs, glutes, and core. Since muscle is denser and heavier than fat, your waist circumference can decrease even if your total weight remains stable. Evaluating walking based only on weight loss is a mathematical error. The true change is the structural recomposition of the body's mass. A clinical trial followed inactive adults who increased their daily activity to 10,000 steps over 16 weeks to measure this recomposition. While participants lost an average of only 1.3 kilograms in total mass, they decreased their waist circumference by 2.5 centimeters and dropped their body fat percentage by over 1. The habit that began as a way to burn a few hundred calories ends by interacting with the very edges of your DNA. Here is an uncomfortable truth about your own mind. Your brain is entirely incapable of accurately judging its own level of sleep impairment. A University of Pennsylvania study divided subjects into groups sleeping 8, 6, and 4 hours over 14 days. The 6-hour group's cognitive deficits compounded to match someone awake for 48 hours straight, yet they consistently reported feeling only slightly tired. They were experiencing a phenomenon called baseline drift. When you chronically shortchange your sleep, your brain recalibrates its internal definition of normal downward. You forget what peak performance actually feels like. Many people insist they belong to the exclusive 5-hour club, thriving on minimal rest. But the genetic mutation that enables short sleep, located in the DEC2 gene, exists in less than 1% of the population. The other 99% functioning on reduced sleep are not biological exceptions. They are severely impaired and completely blind to their own decline. Resolving this deficit requires calculating the difference between time in bed and actual time asleep. Because most people take 15 to 20 minutes to fall asleep and experience brief awakenings, aiming for 8.5 hours in bed typically yields about 7.5 hours of actual sleep. The quality of those hours is highly fragile. Even moderate amounts of alcohol consumed in the evening suppress REM sleep by up to 30%, chemically blocking the phase required for emotional processing and memory integration. Caffeine poses a mathematical problem. With a half-life of 5 to 6 hours, a cup of coffee at 2 in the afternoon still has half its stimulant power actively circulating in your bloodstream at 8 in the evening. This animated diagram shows exactly what that circulating caffeine does. It physically locks into and blocks the receptors for adenosine, the specific molecules responsible for building sleep pressure in your body throughout the day. Screen exposure compounds the problem. The blue wavelengths emitted by phones, tablets, and laptops slash your body's production of melatonin by up to 50%. Those blue wavelengths strike specialized melanopsin receptors in your retina, sending a false daytime signal directly to the suprachiasmatic nucleus, the brain's master clock. These common evening routines delay sleep onset and chemically paralyze the specific biological phases your brain requires to heal itself before your alarm goes off. When those healing phases do successfully activate, they trigger an immense biological sanitation engine known as the glymphatic system, flushing toxins from the tissue. Before this system was described in 2012, the prevailing scientific theory assumed sleep was primarily a passive state, meant for energy conservation and memory storage. We now know it is highly mechanical. A 2019 study published in Science revealed that this clearance process is directly synchronized with the mechanical forces of slow-wave sleep. This visualization shows that relationship. Stage 3 brainwaves, pulsing at the top, physically open the intercellular channels below, pumping cerebrospinal fluid through the system. Naps or meditation cannot replicate this. Only deep sleep provides the fluid dynamics to sweep away accumulated toxic metabolic byproducts. Without the physical force generated by deep sleep, the human brain slowly and unavoidably poisons itself with its own biological waste. This reveals the true nature of an 8-hour sleep cycle. It is a rigorous, demanding process of biological and cellular reconstruction. Every night, your brain actively reorganizes what you learned, repairs cellular damage, recalibrates your hormonal signals, and strips the emotional weight from painful memories. When you decide to stay awake for just one more hour to finish a show or scroll through a feed, you are committing a critical biological theft against yourself. That final hour is the exact period your brain uses for its longest, most intense cycle of REM sleep, rapidly sparking and rewiring your neural connections to protect your cognitive health. Securing 8 continuous hours of sleep is the unalterable biological price of being a conscious, thinking, remembering human being.